Hi folks, we're going to look at the solution for number 16 on page 47, and we've got this limit here. So if I look at all the individual components of the limits, these are all fairly nice square root functions. So normally, as long as the functions are defined for the given x value, they're all continuous. But when we try to input 0 into the expression, we see that we've get 0 plus 1, so square root of 1 is 1, minus again square root of 1, so 1 minus 1 is 0, and we see that the numerator approaches 0, and the denominator, well again these two terms both approach 0, so I have square root of 4 minus square root of 4. So we have the numerator and denominator both approaching 0. So we know the expression doesn't exist at 0, but the limit as we approach 0 might exist, since both numerator and denominator approach 0. Okay, so problem is we don't know whether it's going to exist or not. So we're going to have to try to do some algebra to see if we can do some simplification to see if this limit actually exists. Now, anytime I see square roots, especially in this sort of binomial form, I should be thinking of rationalizing. Except here, I need to get the x's out of the square roots in the numerator to hopefully do some algebra, but I'm also going to have to get rid of those square roots in the denominator. So I'm actually going to have to rationalize twice. Okay, so I'm going to have to multiply numerator and denominator by the conjugate of the numerator. So I'll have to multiply by square root of x plus 1 plus square root of 2x plus 1. Okay, and of course divide by it so that I don't actually change the expression. Okay, but I'm going to have to do the same thing with the conjugate of the denominator so as to sort of free up these variables stuck inside the square root. Okay, so I'm also going to multiply by the square root of 3x plus 4 plus square root of 2x plus 4, and then of course also divide by that expression. So 3x plus 4, 4, and square root of 2x plus 4. Okay, so let's see what this does for us, besides give us a very complicated expression, but hopefully things will simplify out nicely. So when it comes to these first two terms, well, I get my rationalization, and here I'm left with x plus 1 minus 2x plus 1. Notice here how I'm very liberal with the brackets. Okay, I really want to make sure that I don't mess up a sign here. And then of course I've got the square root of 3x plus 4 plus square root of 2x plus 4. Okay, this expression that's still there. But this expression now doesn't worry me because it's not approaching 0. Okay, so now I do the same thing with the denominator, and now I'm going to multiply the first and the third. And that's going to be a difference of squares. So again, very liberal with those brackets, 3x plus 4, which is the square of root 3x plus 4, minus the square of the second, which is going to be 2x plus 4. Okay, and then I still have this bracket here. But again, this doesn't worry me now because that expression with the square roots doesn't approach 0. Okay, so it's not causing me that problem that these square roots are causing me. Okay. So now I just have to hope that this simplifies out nicely. Okay, so here we have x minus 2x, so I have negative x, and 1 minus 1, well, hey, that worked out nicely. Just left with negative x times, of course, this whole thing. Okay, so make sure you're writing this out at every stage, otherwise you're just going to risk forgetting it altogether. Okay, and then in the denominator we have 3x minus 2x. Okay, which is just x, and then 4 minus 4. Hey, perfect. I'm just left with x from this first bracket. And here, root x plus 1. Okay, and here, root 2x plus 1. And of course, these now cancel out. So I've accomplished what I needed to accomplish, which was to reduce out the 0 in the denominator. And so now, what's left, this expression here, can just be evaluated at 0. Okay, so at this point I'm not going to write the limit notation anymore because I'm actually evaluating the limit. So I've got my negative 1, don't forget that there. And so what do we have? So here we have square root of 4 plus square root of 4, and then denominator here, I've got the square root of 1 plus the square root of 1, and of course we'll simplify this here, so 2 plus 2 is 4, so we got negative 4 over 1 plus 1 is 2, and so in the end, this whole big ugly expression reduces to negative 2. Okay, so again, just to recap, anytime you see these two expressions added or subtracted that, well, I guess in this case here subtracted, that cause you a 0 over 0 scenario, you need to rationalize in order to be able to free up the variables so that you can do some algebra and simplify. Okay, that's it for this one.